Today, I and Christine will talk about what serverless observability can Thundra bring to your Honeycomb instance with our great partnership. Let me give today's agenda briefly. We will first talk a bit about the shift from traditional to serverless and what might be the issues when you are migrating to serverless. Then we will narrow down our focus to observability and particularly observability in serverless. Finally, we prepared a demo to you to show you how you can manage to send Thundra data to your Honeycomb instance, and we will enjoy together diving deep into serverless observability data on Honeycomb. But first, let us introduce ourselves.
Hi, I'm Christine. I'm co-founder and CPO of Honeycomb. Super excited to be here today.
Okay, and I'm Emrah. I'm the VP of Product of Thundra, and I'm also very excited to be here today. So let's begin by comparing serverless with the traditional environments.
So where do we come from? The technology world we live in today is getting more and more complex from where we were 5, 10, 15 years ago. We're all moving from a single monolith on 5 app servers to 50 microservices across 500 containers. And we're starting to find that problems that used to be simple to debug aren't as simple anymore. The lines between our environments used to be quite sharp. The code that you ran on your development machine would be identical to that on production. So the first step for tracking down issues would be attempting to reproduce them locally. But with the advent of continuous integration, continuous deployment, the responsibilities of the developer are, they used to be ensuring that unit functional and integration tests passed. And they would say, okay, beyond that, ops, you're responsible for making sure that the production environment is stable. And also, again, traditionally back then, to parallel that clear division of responsibilities within the team, the landscape of tools was also pretty clearly defined. Ops folks use their monitoring tools to watch things like system metrics, CPU, memory. Devs use their logging tools to aggregate and search over text logs, often because it was similar to what they were doing in development. And sometimes, devs would rely on things like APM tools to identify performance or error hotspots in their applications. But all of that is starting to change. The movement of this industry away from monoliths and toward microservices and serverless functions means that it's harder and harder for a small ops team to support a larger team of developers because there are just more moving pieces, more things to interact with each other in new and exciting ways, such that we can't predict what strange thing might happen in production when we have so many more unpredictable new pieces running. And as a result, we're starting to see a breakdown in these rigid boundaries between developers and operators, and so we're DevOps in many ways, and in the boundaries between the various environments. And folks are starting to look beyond monitoring and logging to see what a newer class of tools will let them do. Because as developers are starting to take more ownership of what they're shipping to production, how it's behaving, they're folding their ops, or the word ops, into their definition of DevOps, and are needing to gain the superpower of being able to quickly find out, hey, why is my code not behaving the way I thought it should? And even testing is becoming less well-defined and predictable. Fewer production states are able to be described perfectly within a test environment, and more developers are finding themselves testing locally, then testing again in production by taking advantage of the delicious chaos of production to identify and address edge cases.
In serverless, we love all this chaos, but let me start from the beginning. And the revenue model of the cloud is evolving actually. With serverless, we have reached to a consumption-based pricing model now. And this attracts enterprise companies as much as cutting-edge early adapters, because those enterprise companies have now a very clear option to cut off the costs and yet provide same and even more scalable, reliable, and robust service. Just because of this reason, serverless is a lot way different than any other technology trend. Of course, there are also other things that make it preferable. With serverless, the community gave the management of the platform to the vendor. Old approaches of ops people were already demolishing with the cloud migration. Now, ops people will have to adopt dev skills, and I'm hearing that they will enjoy their new duties and yes, capabilities. Serverless doesn't remove the complexity, it exponentially grows it actually. We now need even more observability through our systems, but the query is now with the code itself. Teams are now taking the responsibility of building the system and keeping it healthy altogether. With serverless, now we are even dividing the microservices to nanoservices, which are dedicated to doing single atomic job and passes the event to another serverless function that gets triggered asynchronously. My 2 cents about this that the market still couldn't come to that point. People were just trying to bring their monoliths to microservices yet, and I suppose we will wait a bit for people to digest microservice transformation. And yes, serverless is stateless by its nature. This can be seen as a no-go for some developers, but this most probably gives the clue about their actual use cases. And serverless is, at least yet, not necessarily compatible with every single use case. However, people choose to keep the state elsewhere and can still benefit from serverless for other pluses. There are even other things to talk about serverless, such as security, code development, repository management, deployment, local testing, and etc. But this can all be a subject of nice webinars. But I want to tie this up to our main subject today. One of the biggest problems with the serverless is reduced visibility. Vendors provide the solutions of serverless, help people to some extent, but it's not always enough when your system gets complicated. There are some issues which are common that I saw during my interviews with Thundra customers, and according to my research, those I can group them in 2 groups, like the ones before going to production and the ones after you go to production. And you know that serverless removes the barriers for everyone to develop. Now, like even you are not an experienced developer, you can write a Lambda function and trigger it somehow. But it also makes it hard to locally test and debug the applications at their local. You need to either use the local versions of the services, but it's not doable for every service. In this case, I saw people generally try to mock the responses from their services. But again, my interviews show that those mocking sometimes doesn't yield the issues that can come across when they are really go to on production. That's why, again, testing in production is now more common. Like local debugging options are also limited. Some specific installation is required for each runtime. That's why people even debug in the production using the CloudWatch logs. But this is definitely tiring for almost everyone. That's why we are like dedicating lots of our resources to make Thundra to decrease the turnaround time for developing, testing, seeing the issue if it is any, fixing it and testing again very fastly using our solution. And deployment is another problem, but this can also be linked to a collaboration on serverless packages. But I think that luckily we have now very nice tools like serverless framework, which eases such kind of tasks drastically. At Thundra, we are also mostly using it, and we are very happy with it in terms of reliability. And the issues after going into productions are, I think, more serious. Security and monitoring are the problematic parts for us. Like, right, you don't manage the infrastructure, but you are still responsible of your application to be secure and reliable in the production. The vendor takes the responsibility of maintaining the host security, but it is still your responsibility to take care of the security of your applications. Your serverless application is still open to threats of SQL injection or any type of injections you can think of. You still need to use third-party dependencies that you cannot trust completely. You still need to catch up with the newer versions of those dependencies. The worst thing last, people can now trigger your functions many times to make your function run forever, and this will cost you too much. And this is called denial of wallet now. If you want to prevent this by putting a concrete execution limit, then you make it yourself as a denial of service. In this case, you need to have the correct security configuration, and you need to also give only necessary permissions to your Lambda functions in order to prevent them in case of they somehow got compromised. Monitoring is also another problem for Lambda that we will be talking about in a minute. On top of many challenges of observability in serverless, it is very difficult to get the monitoring that you want actually. Vendor provided logs and metrics and traces are okay, but when you have more complex functions, it's getting harder to manage your architecture with separate tools like, let's look at CloudWatch now, let's go back X-Ray, let's go back CloudWatch again. You better have one tool that shows metrics, traces, and logs all together. There are also other problems. First of all, there is no place for your traditional agents to put. The container that vendor launched for you will be a history when your function aren't invoked for a while. So you need something else, but not agents. What Thundra provides the libraries which instruments your code during runtime and gather necessary metrics. But in this case, the only time to send the data is during invocation. This means that sending monitoring data out of invocation will slow down your invocation actually. Thundra's solution to that is actually leveraging CloudWatch logs and sending monitoring data asynchronously from CloudWatch logs. And we believe that this method is particularly useful when we are monitoring time-critical Lambda functions, like which are stick with the API calls in production. Now let's talk about our issue today, which is full observability and how we can achieve it in serverless. And I'm giving the floor to the expert, actually.
Thanks, Emrah. I want to take a minute and talk about the definition of observability as distinct from monitoring. So we think of monitoring as a technique for finding out when the world deviates from your expected version of reality. Often you're looking at your system, you know how it should behave, so you can define a threshold for what acceptable behavior is. And then you can watch the system and alert when it deviates. You just have the robots do the obsessively staring at metrics to see how it behaves. Monitoring, again, traditionally tends to be ops-oriented. Things like monitoring CPU, disk space, memory are very common, kind of out of the box things to have. And because often the acceptable behavior is predefined or the system is well understood and there's these predictable bounds, there's often a known remedy. Something like, crap, I'm getting paged because disk space is high. Well, okay, remedy is I need to run a cleanup job or provision more nodes. And so it's great for keeping an eye on known problems, but that means that if it's unknown or if you're encountering something new, more often than not, engineering actually has to get involved to track down an outlier or figure out why is it doing that? What's happening today? And good engineering teams will eventually get around to automating those known problems away, whether with self-healing systems or better alert hygiene. Observability, on the other hand, is a term we're using to describe what we're starting to need to do with these more complex systems. When the problems that impact production can't be predicted anymore or can't be explicitly watched for because you don't know what to watch for, you can't rely on a technique that relies on defining and watching these known bad conditions. Instead, we need a tool that's much more flexible and can look through data, look through what your systems are producing to track down new and unpredictable issues. To start from your key performance indicators and filter out the noise to isolate some strange segment of your traffic. And observability tends to be more support or dev friendly. By making the tool itself be able to deal with more flexible questions, you turn the task of tracking down outliers into something that maybe support can be the first line for, instead of having to jump straight to, hey, ops folks, can you add some new metrics? And observability tooling can also work and should also work with more flexible schemas and high cardinality data to better reflect this more complex world we're working with and to speak the language of developers rather than just operators. While we're used to talking about tools in terms of data, Honeycomb, and some folks will talk about observability having 3 pillars. We at Honeycomb actually tend to look forward and think about observability as an actual ability that you might have to use tools to tell new stories about what's happening in our systems. When I do the demo, when Emrah and I kind of play around, keep an eye out, because while we'll be showing some queries that we've prepared ahead of time, the real power of Honeycomb is being able to take any query and dive in. What we try to do is, instead of just say, hey, here's your data, congratulations, you're done. We want to give you the ability to almost start with any graph and stick your hands inside the screen and say, yes, but I want this graph with these new filters, or broken down by this other thing, or let me follow this hypothesis, let me validate this, and do it right from the graph, so that you never feel like you're stuck or you're up against a wall where you can't go forward. Because relying on dashboards means that we're relying on these known artifacts of past knowledge, past postmortems, past incidents, and that constrains us to what we happen to know to ask about in the past. But when there's some entirely new issue today, when some crazy customer comes online and starts doing something terrible that starts thrashing our shared resource in an unexpected way, we need to be able to isolate that. We can't be left blind staring at questions that we asked 2 months ago. And black swans are the new norm. These things that only happen once in a while, there's just more and more ways for them to happen, impact our systems and impact our customers' experiences. So we can't let ourselves fall back to this pattern of pattern matching, scrolling through dashboards, trying to figure out what matches what's happening today. Instead, we have to be able to visualize trends, use our unique human eyeball ability to find trends and pick out patterns, and be able to validate hypotheses quickly to address an issue.
Okay. By its nature, serverless cannot be sustained with traditional monitoring approach because, as Kristen says, that there are also lots of questions to ask, and it's distributed by its nature. While the transformation to microservices from monoliths still goes on, the pattern in serverless is generally handling such a normal service with more than one function. And each of those functions does a very atomic task. And most of the time, this architecture works asynchronously between those functions. For example, an endpoint that saves the user is now a serverless architecture of an application. A function actually saves the user and notifies another function, which creates the first invoice from Stripe, then another function, which adds this user to a default team, and so on. All those things happen asynchronously, and now there are even more unknown unknowns. In such environments, developers are still forced to use the default metrics provided by vendors. For AWS case, yes, I can add my custom metrics finally, but it is still not very helpful to dive in CloudWatch logs when things get that complicated. When customers need to have more visibility through their systems, they generally need to have some other enablement to learn about their unknown unknowns. Thundra comes into the scene at this point, which lets you instrument your functions automatically or manually with any kind of a flexibility you can think of. We recently released a blog post about how we think that developers should mind observability while they are developing their serverless architectures. We are showing in this article, it's handy to have a tool which helps you to understand your functions with automated tracing, but you also need to add anything that you may think and you may want to these existing spans, or you can also create your own spans according to your needs. So this is actually a quotation from a Honeycomb customer.
Yeah, so while we were actually getting ready for this webinar, one of our customers tweeted out this trace graph and the realization that, trying to rely on vendors or trying to rely on metrics to dive into really understand what's happening with a function, you often need a little bit more. You need a tool that is specialized and a little bit stronger at doing that dive, doing the sort of analysis that helps you find out that, hey, very few or a very small percentage of my traffic is taking up to a minute to go from one function to another. And this customer was able to pass trace context through, visualize this, identify it. And for me, this shows that the AWS team, even the AWS team, needs to test in production sometimes because there are outliers they couldn't predict. And first step is finding them. Second step is digging into this one to figure out why it happened. And to AWS's credit, someone from the AWS team actually kind of jumped into this thread and encouraged him to ping support so that they could dig into it.
So let's come to the demo. I would like to say that we developed our Honeycomb integration to enable Honeycomb customers to use Thundra data with their favorite platform for observability, which is Honeycomb. It was very nice to have a partnership with a company that we share the common vision for observability. We enjoyed our Honeycomb integration and we enjoyed digging into our data sets using Honeycomb. I'm going to make a quick demo of our experience now. My demo will start with the setting up Honeytail to your account, which lets you forward the Thundra data to your Honeycomb instance. Then we will show how you can configure your Lambda to make this redirection. We will then see how we can visualize the invocations and metrics and traces on Honeycomb. Then I will play with the different data sets with Christine, and I think you will also enjoy that part. So before you want to try our Honeycomb integration, we require you to get a license key from us. For that, you need to go to one of our website pages, which will be given at the end of the presentation, and we will get in touch with your license key, which you can use completely free for a month. After you get the license key from us, we can initiate the setup process by installing Thundra Honeycomb integrator to your account from AWS Marketplace. You will go to AWS Marketplace and find Thundra integrator for Honeycomb with the link that will be provided at the end. You can directly launch the CloudFormation template that we provide in this integrator. This CloudFormation template includes a Honeytail and a Thundra receiver, which transforms the data with the Honeycomb compatible format. When you launch the CloudFormation, you will be navigated to a CloudFormation service. There, you will make some necessary changes to set up the integrator. You will enter your Honeycomb API key and Thundra license key to complete the installation. Remember that in order to restrict the permission to send data to Honeycomb, you can set Thundra allowed API key prefix area or Thundra allowed API key area. In our screenshot here, they are both empty, but it is strongly not recommended here because in this case, every Thundra agent that knows the URL of your Thundra Honeycomb integrator can send data to your Honeycomb instance. After you finish the installation of integrator, you will see that Honeycomb URL in the output tab of the configuration. You will use this URL to configure your Lambda to send the monitoring data. To use Thundra in your Lambda function, the easiest way is now to set Thundra layer from AWS console. There are also other ways, but after Lambda layers are proposed, we are very happy to see how practical it is with Thundra layers. You can use Thundra layers for Java, Python, and Node.js. If you don't want to plug with the layers, we also provide setup with serverless framework or completely manually. For all of that, you can visit our documentation. After you set up Thundra to your Lambda function, you will now configure Thundra to send data not to our SaaS platform, but to your Thundra Honeycomb integrator, and it will forward this data to your Honeycomb instance. Remember, the Honeycomb URL that you get after you set up the integrator, you will put this URL to Thundra agent Lambda-based report URL environment variables, and you are done. Now your Lambda functions are sending data to your Honeycomb instance. It's passing through your AWS account. It's not coming to us, and it will be completely between your account and Honeycomb now. Let's have a look at the different data sets of Thundra on Honeycomb. Okay, for that, I will start with we have different data sets actually, which are invocation, metrics, span, trace, and logs. Invocation is kind of a roof data set. It gives you about the general usage of your Lambda architecture. Let me show you a query that I made before this webinar. In this query, you can see that how your functions are actually behaving in general. You can see the spikes here. Your function, Java function team list somehow increased their duration, and your build cost is jumped at the same point with no surprise actually. You can understand what's happening, and you can add any kind of a query that according to your usage. And let's check now what you can do with our metrics data set. For example, you can say that, hey, show me how the CPU percentage of my functions and memory usage is changing. Here you can see a spike about how your function is actually doing with the CPU load. Here it's 40% of the CPUs get by team get functions, and at the same point, it's also use memory is also increasing. Then you can zoom into this point and understand what are the raw events here. So let me show very quickly again what you can do with the log data set. You can say that, hey, in my function user get, I want to get every log message that contains this particular keyword, which is, in our example, retrieve. And you can see that my user get function has retrieved users with these IDs. And you can understand like how many times these logs actually happened. And to be honest, like the coolest part with the Honeycomb and like Thundra integrator is the span dataset. Using that, you can say that, hey, my team get function is like interacting with a DynamoDB table. I want to see the invocations in which this interaction takes more than 50 milliseconds. And you can see that like, hey, here it is, like there are two functions, there are two invocations that takes more than 50 milliseconds for Dynamo invocations. And you can go into this trace chart and see that like in this here, your function goes Dynamo, and you can see that like what was the request, like what was the arguments, what was the return value, and you can like filter according to this. And you can also see if you have a function here, you can see that what were the arguments, what were the type, what were the return value, and like I want to show also like when I click on this span, you can also trace HTTP endpoints with Thundra, and it shows you that hey, your function gets 200, it's okay, and this was the endpoint, and it's okay. And there's also Redis here. You can get the hey, it first tries to read from Redis, and it couldn't find apparently, and it checked from the Dynamo. Like you can also do, for example, I want to show one more example about like our span data set. My function user get, how it is actually doing with Redis, like how many times it's reaching to cache to make a get comment. You can see here that user get is making some get comment here 2 times and in 2 invocations, and you can understand it. And in this function, in this invocation, you can also see that this application is going to a PostgreSQL table and makes the query. You can see the exact query here, and you can understand if your ORM, if you are using one, making some inefficient queries. So I want to pass the word now to Christine, and she will also, I suppose, show her explorations with our data set. I'm stopping the share, Christine.
Great. All right. Here we go. All right. One of the things that's the most exciting to me when I get to play with a new data set is seeing how I can level up and how I can learn based on what people in the team are already doing. This is our Honeycomb homepage. On the right-hand side, you can see the data sets that Emrah mentioned. And one of the things I really enjoy is just starting off by seeing what have people been doing. Here you can see I've been playing around, it looks like this morning most recently, but when I wanted to just kind of start leveling up, I just started poking around to see what Emrah had been doing, which data sets he'd been playing with. One of the things and the behaviors within a team that we try to emulate with Honeycomb is this feeling of, oh, I don't know, I'm not sure what the right answer is or how to start, or maybe I'm new on the team, but let me peek over the shoulder of this expert and see if I can learn just based on the actions that they take when they're on call or when they're investigating a sort of issue. So up here, Emrah had his visual board. I've got a separate board. This one's a little more compact, which is why I like to be able to scan things. And one of the first things I found was using the invocation data set. I was curious. I'm a developer by trade, and so I am curious to find out when things are erroring, why they might be erroring. And I was delighted by how easy it was to do things like pull out runtime and error type and find out that, well, this is demo data, and so a demo illegal access exception seems to be thrown back quite often. It seems totally fine. And one of the things I wanted to show off, like I mentioned, everything is very editable, very quick. I can start with this graph and say, actually I want to see errors compared to non-errors, and I want to see how many, in fact, have, what proportion of requests are throwing errors at all. And so we can see a little bit better here. These are all completely fine requests, but demo legal access exception still being thrown fairly often. Over here on the right-hand side, as I run queries, I even have this you can think of it as like an infinite undo stack of queries that I'd run, just playing around so that I always have the ability to go back to an interesting query, even if while I explore, I jump into something kind of, if I run into a dead end. Another thing I like to show off, lots of folks talk about how line graphs or percentiles only tell part of the story. We say yes, and instead we're going to help folks visualize the distribution of some metric. So this graph up here is a heat map of the duration. And a heat map you can think of as a kind of scatter plot. This y-axis is how long the request took. The x-axis is when the request happened. So we can see there's lots of, this darker color means that there's been lots of requests that are very fast. If I zoom out, I can see that almost everything's very fast, but there's some very kind of suspiciously slow queries up here that are blowing out our, that are kind of above and beyond in terms of requests taking a longer period of time. And we've got some statistics and a nice summary table down here. One of the things that we really want people to be able to do with something like Honeycomb is, I mentioned, kind of looking at a graph and say, okay, but why? And to dive deeper and to isolate the noise. One of the things that Emrah did was just assigning a filter and saying duration above some certain threshold. That's a great way to go about that and can be incredibly valuable, especially if you're diving into a particular customer or a particular function. But here I'd like to actually show off a new feature that we released, that's still in beta, that supports this workflow directly. With Bubble Up, I can say, okay, here's this heat map and the scatter plot of requests that have been happening, and I think that these are interesting. And so by selecting this, Bubble Up will actually tell me what is special about these requests compared to everything else, right? If these are taking, I don't even know how, 1,000 seconds, why are they taking 1,000 seconds? Which requests are taking 1,000 seconds? And what we've done is, for every column that exists on these events, we can let you really quickly dive in to see, okay, well, some of these user requests are represented inside the selection, and some user saved values. And most of the other functions do not seem like they're inside this selection. It seems like most of the other functions must be completing pretty quickly. We can see cold start is exclusively associated with the selection. There are no cold starts that are fast outside the selection. And I can learn a little bit more about the ARN, region, and what this does is it helps me start to narrow down things that are interesting about my system, helps me find and pinpoint the exact requests that are interesting. So I can say, well, I want to filter to cold start as true, and I can flip to the raw data and I can actually see the structured log line with all of this context for each individual invocation of a function. It's a really powerful way to get from a high level view of, remember, how is my latency doing? What does this look like? All the way down to tell me more about this individual invocation. One thing I really like to show off, Emrah mentioned the span data set contains all sorts of data about the execution of the individual request, and you saw that cool trace view. This is the default dataset view. So if I was just coming in not from a board and I just clicked on span the dataset, I would be dropped here. And we've got some starter queries for you. And this is something that tells me about the slowest traces, or in this case, the slowest serverless functions that are invoked in my system. I can click, and it tells me over the last 2 hours. Looks like it's about 30 seconds. Remember the heat map I was looking at, I ended up expanding to about a week. So good. Over the 2 hours, it's only taking about 30 seconds. I'm actually not going to click straight in. That's what Emrah did. And honestly, it's my favorite way of getting into traces. But I want to talk a little bit about traces and why we think this sort of visualization is so useful. A lot of tracing products, a lot of tracing experiences are very good at the visualization of the trace, but they're not so good at telling you which visualization or which individual trace is interesting or worth digging into. Many of them will sort of just give you a list of traces for you to select through. And one of the things that we've always prided ourselves in is, hey, with Honeycomb, it's so fast and so easy to get a high-level view of what's happening. You know, I can do things like, maybe I only care about Java functions. Maybe I want to break this down by version. This actually might be all the same. Yeah, all the same. There's something powerful in starting from a really high level and then saying, okay, well, now tell me which traces are interesting. Now that I've filtered down to this one user that's complaining or this new endpoint that I've just released, now show me an example of what the execution of my code looks like. And this traces tab gets you a summary of some of the 10 slowest traces in the selected time range. And so with this, I can say, well, maybe, I don't know, maybe there's some timeout and I'm actually going to ignore the slowest one. And I can pick this one down here. It just gives me a little bit more of a granular way to select which trace I want to visualize. And the thing that I find so exciting, you know, Emrah pointed out a lot of this exciting metadata on the right-hand side. For many tracing tools, this is where it stops. I love to say, well, okay, let's say, you know, I'm a new engineer on the team. I'm poking through this data, and I'm surprised by how long Dynamo takes. I'm surprised by how much of this 1.359 seconds is taken up by this call to Dynamo. I can do something like, okay, I've learned something about the span, tags DB type, and I'm going to, I'm going to actually plug that into my filter to learn more about it. And I love talking about this because it lets me slice into a part of a trace. Previously, we've been talking about traces as a whole, the parent ID, or sorry, the parent root span. But no, I want to talk about, ooh, darn, what was that? I want to talk about tags DB type. And I can actually do things like show me how much time overall is being spent in Dynamo. Show me, this is the sum over all invocations of a function. Show me, you know, whether there is one platform or one type of work or one customer that is consuming many resources for Dynamo. This part may be not surprising to you. You know, Emrah may be sitting there being like, I know the system. Of course, Java is consuming most of the Dynamo resources. But for me, someone who's just exploring, this is exciting, and it teaches me about the system. It teaches me about the workload, and the next person that comes in can, again, poke through this activity tab and learn about what I'm doing. And I think one of the things that is the most exciting for me with poking through the Thundra data is how much rich data comes automatically. The fact that Emrah could just drop in those lines, and you know, this new engineer without doing any work, him doing a minimum of work, can dig in and learn these things about my system is so exciting. And I'm, you know, yesterday we spent some time playing with this data set, and I just kept getting giddy, just showing up. wanting to show him the graphs that I'd constructed.
On Thundra side, you just need to like add your layer or like set it up like with the very easy like library importing, and it will be automatically start to sending this information actually. And like now then you can enjoy like the flexibility of querying and visualizing with Honeycomb, and it really made me very, very excited about like to see my data that flexible with such a great tool actually. Like I cannot praise the Honeycomb now like more, I can say.
Anyway, I'm not going to run folks through all of these other queries, but I don't know, let me check to see if there are any questions, but we have had a great time kind of playing with this data and would love to kind of field any questions folks might have about what it's like to use Thundra for serverless, use Honeycomb for observability, what it has been like to play in this overlap between the two boundaries.
Thank you, Christine, actually, to let us to make up this webinar great, and like to let me play with your actually I want to thank for Honeycomb on behalf of everyone here. And like these are the resources that you can reach off. We already sent some of them in the chat, and you can always like get your license key from us and start forwarding your data to Honeycomb. You can also play our SaaS environment using demo Thundra.io. And you can also see the new Honeycomb book, which is actually very quite informative for me also, like how you can like plug observability while you are developing. I think we can now jump on questions and answers. Before like question, I'd like to ask a question to Christine actually, because while we are developing the integrations, you know that we were been making profiling for Java, and we will be doing it for Node.js and Python in the future. We want to have some kind of a flame graphs that we can show our profiling data. And like, I know that Honeycomb will also do a great job to do this, but like, I want to ask about like, what do you think about this, Christine?
Oh man, if we could only do what we wanted to do, exclusively what we wanted to do, we would just do visualizations all day. I think flame graphs are definitely something that we have wanted internally. I can't promise it will be one of our priorities for the next several months, but certainly the more we hear from customers about a specific visualization or a specific way of working with their data that will help them, the more we can try to make that happen. The things like the heat map that I showed you is something that came from folks starting to agitate internally, externally about line graphs not being enough. So the more that we hear about flame graphs, if anyone else on this call wants to chime in, the more that we can try to prioritize that.
Okay, thank you.
And actually, a question for you, Emrah. One of the things that we think about a lot is helping folks get data in, and I love how easy the layers make it to get all this automatic data in. What is it like to add custom data, and what do you tend to recommend people? How should people think about taking that first step to adding extra data, or do you add extra metadata?
Yeah, like the Thundra journey that I saw from the customers that you know that we are giving the layers, and like automatically we are tracing the integrations, which I mean like SQL queues, SNS topics, DynamoDB, your like HTTP endpoint calls. You will be seeing traces of those automatically. But like as I said in the presentation, you sometimes want to add some custom metrics to these spans, and you can also create your own span using manual instrumentation. No, we are open tracing compatibility. You can start You can start a span inside your function using manually by writing code. I saw from people that they just like gets happy with the like default integrations, see what's happening with their functions and the integrations. After that, they start to ask more about their data, because like when they understand that they are able to ask questions, they are asking more and more. Like, for example, they want to say, hey, I want to trace my arguments here. I want to take, I want to see that like exactly this part of the function takes how long, and how is my variable changing. You can do all of this using instrumenting your function manually. And the automated is coming from like for the integrations actually.
Cool. I actually have another question. If I have a service that I control calling out to the serverless function, how does Thundra instrumentation work with that? Can I pass headers through to
yeah, for our like existing integrations, we already intercept with the query, with the communication here, and we wrap up with our code. But like, let's say that you are now like trying to get a service that we don't support. You can like, as you say, give your headers with the manual instrumentation, start your own span, and put your headers to inside of this span as a tag. And you can see this data on Thundra, and in our configuration now on Thundra data with Honeycomb, you can make every unsupported integration of Thundra supported by yourself actually.
Cool.
I'd like to say also about the our sampling capability, because it's also another concern for people. Like, yes, we can do all of this, but like, do I need to do this all time, always, because like it will generate too much data to me? Like with Thundra, you can make sampling. You can make something rule-based. Like, for example, you can say, hey, don't send every single invocation, but send one of every 1,000. But you can say, hey, bring me only the erroneous invocations. I don't want to see the normal ones. And you can also say that, hey, if my function takes more than, let's say, 300 milliseconds, I want to only see those invocations in Thundra, and which means like in Honeycomb now. I think it's very cool for people who are concerned with the data usage of their environments, because, you know, like we both as a product, both Thundra and Honeycomb is like the storage-based pricing, and it's we want to help people to understand their data and example if it's possible.
Sampling, another way that the two of us are philosophically aligned. This is great.
Yeah.
Okay, thank you everyone for attending. We are being shooed off. For anyone who didn't see what Kelly mentioned, Kelly's been chatting out, this will be recorded and made available sometime, probably next week at the latest. So thank you so much for joining us. Feel free to chat or email us if you have any questions. Have a great rest of your day.
Thank you, everyone.